So the last feature I just want to show you guys is IPFS. It's a similar storage utility. One thing with IPFS though is that everyone has access to that data. If they know the hash and it's not, symmetrically encrypted before it's uploaded, anyone will be able to retrieve that data. So here we'll go into ABC's instance and we can open up the UI to interact with this. Click on the connections. We'll see that he's connected to the other IPFS node in the cluster. And now we can go ahead and just, create a folder, create one called artwork again. Now we can jump into the folder and we can upload files. So I'll just upload that Basquiat file again. And then our other node will be able to immediately download and inspect that file as long as they're aware of the hash. So here's the file that's been uploaded to IPFS. I can go ahead and copy the hash, and then I can hop out of this, go into the other IPFS node owned by XYZ. I need some app credentials to securely get in there. And then I can just enter that hash. Okay, and now I can inspect that painting that we uploaded. So I think everyone is likely very familiar with IPFS. Obviously, it was originally built for decentralized mainnet public implementations, but you can still leverage kind of the storage utility functionality within a private or a permission network. You still have the ability to pin files. You still have that censorship resistance. And you can, as I mentioned, you can encrypt the files before you upload them to give you some heightened levels of security as well. So there's the three components that I wanted to show. I'm gonna hop back into the environment and I'm gonna grab the chat real quick here, and then I'm gonna show you guys an actual full stack demo. Sergio Lopez, is there a retry mechanism when calling the external API in case it is down or loaded? Which API is that, Sergio? Maybe you can toss that in the chat too. Yes, this is being recorded, Sebastian. Thanks, Andrew, for asking that. No, they're not, Frederick. You need to manually actually use the IPFS API and pin those. There is I believe there's a cleanup that happens at I might be wrong. I think at 10 gigs of storage, there's an automatic garbage collection that occurs. We can take that offline to discuss that and give you a more accurate answer for sure. So the last thing I want to show you guys is I want to weave together all of these components. I want to weave together document store, on-chain registry, event streams, smart contract interfaces, and the REST API gateway. And I'm just going to show you how this looks in the scope of a private data exchange, a decentralized data marketplace, where every organization, every application is going to be notified in real time of the existence of new pieces of data that they can then potentially purchase, or if they're the uploaders, that they can transfer to other organizations in the network. And so this could be applicable to credentials or certifications. It could be legal contracts. It could be pharmaceutical trials. Any piece of private data that has quantifiable value for your industry, for your use case, and that needs to be protected and not put on chain in plain text. So there's a bevy of scenarios that this is applicable to. So I'm going to log out of this account and I'm going to go into a different one that has our demos. And we're going to look at this through the new console as well. So here we have our data marketplace environment. And now I have three instances of ADAPT. I have organization 1, organization 2, and organization 3. And what we're going to attempt to do is we're going to have organization 1 upload a document. Organization 2 has great trust in organization 1, so he's going to be notified of this new published document, and he's going to say, hey, I've purchased a lot of stuff from you in the past. I want to purchase this document. We're going to use some basic token economics to pay for that document, and then we're going to update our blockchain with different state changes, that a document was available for purchase, that it was purchased, that it was rated, etc. And we'll see how in real time, using those event streams, organization 2 and organization 3 are going to be made aware of all of those state changes. The fact that a document was published, the fact that it was purchased, and the fact that it was rated. So first thing we're going to do here is we're going to publish a document. So we're going to give it some innocuous metadata, and this can be configured, specifically, bespokely to your use case. I have some dummy IDs that I haven't used yet before. So we're going to just call this example private data 72. And now I'm going to go ahead and grab my file, go into my little dummy private data directory, and I'm going to grab this text file. This is just boilerplate nonsense right here, just a bunch of different strings. But obviously in real world, this would be, those pharma trials, this would be a contract, this would be, something that's sensitive and something that has, like I said, quantifiable value. So I'm going to go ahead and open that, and I'll go ahead and submit it. And this will be a blockchain transaction. This is going to say, hey, there's a new piece of data. It's the hash of this payload of that text that we just looked at, and it's going to have these two pieces of metadata associated with it. That's going to be put into a marketplace smart contract on the blockchain, and everyone else in the network is going to be made aware of it. So this is just a single transaction right here. Go to the Block Explorer in the dashboard. We see our single transaction come in, and now we can go to org2. We can search for that. We're made aware of it in real time that this was published and authored by org number 1. Same goes for org number 3. And this is thanks to that event streams functionality. So now org 2, using the token balance that he has, is able to purchase this document. And when the document is successfully transferred, then there will be another smart contract invocation saying that, yes, the document has been purchased by org number 2. So we're going to see 2 transactions take place here. We're going to see a token transfer, and then we're going to see another update on our marketplace smart contract saying that this document has a purchase by org number 2. So go ahead and select it. Take note of the token balance down here. And this should decrement by 10, and it should increment org number 1's balance by 10. So that goes down to 560. I think this guy was at 1700, so he goes up to 1710. We see the update in real time of 1 purchase. We also see the update in real time for org number 3. And now we have the ability to rate it. So if we go back into our Block Explorer, that was 2 transactions, as we said. That was our token transfer, and then that was the update of the marketplace smart contract. And then the last thing that we can do here is we can rate it. So we'll go ahead and rate it. This will be our 4th transaction, and we should see in real time, as soon as this event is emitted, this gets updated to a 5-star rating. So there's our 4 transactions that we just submitted, and this was weaving together all of these components: the document store service, the on-chain registry service, our smart contract management, the REST APIs, the gateway, and then perhaps most critically, these event streams as well. So I see there's a few more questions in the chat. I'll try to grab those. Oh yeah, it's a great question, Sergio. Yeah, so that automatic retry logic is built into the Kafka tier, the Kafka tier. So you're gonna get guaranteed at least once delivery inside of that layer right here. So you have that logic built into the delivery. So yeah, if that API is down, Kaleido is going to continue retrying until you're able to get those. So those events, those JSON payloads are just queued and buffered into Kafka, and then they're going to be delivered once that API is callable again. It's a really good question. Okay, I'm going to go ahead and unmute everyone just because I know chat's not always the most pleasant way to go. But I will say thank you everyone for attending. I'm going to put my email in the chat as well real quickly. So if you do have any technical or commercial questions, you want to talk more about your use case or any financials, please do not hesitate to reach out to me. We can dig into the Kaleido stack. We can dig into your use case, talk about our different packages, etc. Everything's on the table. So I'll just unmute everyone super quickly here. And if you have something that you'd like to say out loud, please don't hesitate. And if you don't, then we will wrap this up and we will reconvene next next Tuesday, where I'm not quite sure what I'm going to show yet, but we'll definitely try to expose some of the other features inside of Kaleido. I don't know if we've shown app-to-app messaging yet, so that may be a good candidate. And then there's a lot of other new features that are being added into Kaleido. So I'll just drag my feet here for about 30 or 45 seconds if anyone wants to say anything. And if not, I will go ahead and wrap it up. Yeah, so the purchase, two things happen. The first thing that happens is there's a token transfer, meaning that, hey, you can't get this document unless you actually give me some token balance, right? The logic is saying, hey, I need 10 tokens in order for me to transfer that document. Once the counterparty gets the document, they're going to give back an acknowledgement receipt to the sender. And once that comes in, basically, once all of that handshake occurs and once that sign verify logic occurs, then you have your second transaction. So the first one is the token transfer, and the second one is saying, hey, this was successfully purchased by org number 2 in our case. Basically, org number 2 acknowledging that he successfully received that document. And then the rating is just a single transaction. So the bulk of the events and the bulk of the logic are actually on this marketplace smart contract that has these events like purchased and rated and published and one or two other ones.
Sorry, I think I can speak now. Can you hear me?
Okay, the question is, but the second one is created from the smart contract, right? Yeah, there's basically mandates, right? First, the tokens need to be successfully transferred, right? And once that token transfer is successfully completed, then the second smart contract is invoked. So the first one is our ERC20 smart contract. The second one is our marketplace smart contract.
Can you hear me?
All right, so it looks like there is a request for app-to-app messaging next week. We can definitely put that on the docket. It's a very, very easy one to show. It follows the same flow as document store. Obviously, it's not dealing with huge payloads. You know, this is something we would use in a financial use case or just, you know, an acknowledgement or a ping. But those payloads are also asymmetrically encrypted and transferred via Kafka, via that same plumbing layer. All right, well, thanks everyone for attending. I'll give you 23 minutes back of your Tuesday.